everyone. Welcome to week 2. Hopefully you can hear me and you can see my screen, right? Okay, thank you. So first of all, an acknowledgement of the country. I would like to acknowledge the traditional owners of Australia and recognize their continuing connection to land, water, and culture. I am currently on the land of the Burra Matagal people and pay my respect to their elder, past, present, and emerging. I further acknowledge the traditional owners of the country on which you are on and pay respect to their elder, past, present, and future. So today we'll have a look into the conceptual logical design and especially how to draw an entity relationship model, or also known as entity relationship diagram. Okay, so in short, that is known as ERD. So that is what we are going to learn today, how to draw an ERD from specification. Okay, so first of all, we will have a look on the notations, what notation we'll use for which purpose, and from there we will try to figure out entity, relationship, attributes, different keys, and then some advanced features as well. Okay. So why do we need to learn about conceptual database design? Because customer who will give you the specification, they might not be technical people, so they don't understand those technical terms. But as a developer, you do. So there is a gap between these two people, right? So to bridge this gap, we need this conceptual database design so that we can agree on the structure of the database before starting the implementation. Okay. So that everyone can have a look what is it that you are going to implement later, so that there is no misconception. There are a lot of names on the web. Okay, so here is only one. If you don't understand the requirement clearly, then what can happen? So this is what has been proposed by a project sponsor, that they want something like this in tree. Okay. But when they wrote it, writing prompt was not clear, or for any other reason, this is what you understood, that this is what they are looking for. They wanted 3 plate, but now you got 3 strings. So that is what you have got. When a senior architect designed this project, this is what he has designed, because he didn't understand the specification clearly. Okay. When it goes to the engineer, this is how engineer is trying to install this one. Okay. And finally, when you are delivering it to the user, then the target is anyhow to install that software to that customer end, and that is what you are doing. But after receiving the customer might say that this is actually what I wanted. Okay, so it's really very important to figure out the requirement first. What is it that the user wants? Okay, so that we can deliver the correct product. So there are many steps in the software development process. We will not talk about application development, only the database design part. Okay, so in the software development project, there are many steps. The first one is requirement analysis. Here we are only worrying about database design. So in this requirement, we will try to figure out what data needs to be stored, what application must be built, and what operations will be there regularly. Okay. So after we get that requirement, from there we will try to design this conceptual model. Okay, so that is what we are going to learn today. So this is a high-level description of the data, closely matching how the user think of the data. Okay. Once we have this conceptual design, from there we will try to make the logical design, which is actually creating the tables. Okay. So this is what we are going to learn next week. We will convert this conceptual design into logical design by creating the tables. Then the table that we create, those tables might have some issues. Okay, that might be a bad design. If one table is not performing as expected, we might need to do some refinement in there. So that is what we are going to do in schema refinement process. So identify the problem in the current tables and then refine if needed. After that, we will, once we have this logical design, So we'll actually implement those into the DBMS system, like we are using PostgreSQL, right? So in that PostgreSQL, we will implement all of those tables inside the data and do everything to create the application that is required. Finally, there could be some security measures there, like which user should have what sort of role. Okay, so those sort of thing we'll figure out, and that's when the design is complete and we will deliver it to the customer. So we'll learn most of these things, almost everything except this last part, how to provide this security. Okay. Other than that, we'll learn all of these things in here. Today, we'll only talk about the conceptual design. So we'll have the requirement. From there, we'll try to create the conceptual design. Okay. So what does conceptual design means? Conceptual design simply means that we need to represent the requirement graphically. So the user requirement that we get, how we can represent that using pictures, okay, using different symbols that we are going to have. So when we are talking about conceptual design, we are not worried about the data from the time being. Okay, how data will be implemented, how data will be created or modified or used, that is not of concern for the time being. Okay, only we will talk about the structure of the tables or what sort of information that we need to store. Okay. So that is what will be of concern, not the actual data. The entity relationship model that we are going to learn is designed by Peter Chen in 1976, a long time ago. So this is a very well-known model, okay, also known as Chen's model. There are some improvements in that model as well, and those are known as enhanced or extended ER model, and that is what we are going to learn. Okay, so EER, extended or enhanced ER model, that is what we are going to learn today. So the name suggests that this is an entity relationship model. So first thing we need to figure out what is entity, then which tables should be relationships, and how we should combine all of these to create the model. Okay. So that is what we want to do. Okay, so let's start with entity. What does an entity mean? So any individual object that you can think of. Right now we are running this session, right? So here, teacher, I am an entity, student, you are an entity, right? I have a computer in front of me, that is another entity. So if we want to gather the information about all of these entities, that's when we will create an entity set. So an entity is any object, any student, any course, any account information. When we put all the students' information into one table, that is known as entity set, or simple terms, table. Okay. So entity set simply means one table. There we will have the information of all the students or all the courses or all the bank accounts. So the symbol that we are going to use is rectangle for entity set, okay, or for a table. Entity set is same thing as tables, and rectangle box will be used to represent that one. Okay, so whenever we see a rectangle box, we will now from now on we will understand that that is a table and that stores information regarding something. Okay. So definitely in a table, what do we have? In a table, we will have a lot of columns. The column heading that we will have. So those column headings are known as attributes in database term. So in an entity set, we will have attributes, and those attributes will be represented by Eclipse. Okay. So using Eclipse symbol, we will represent those for a table. Okay, so in here, rectangle box is the actual table, and these are the column headings that we have. Okay, so attributes simply means, as an example, let's say we have a table called people. There we can have IDs, their names, their addresses. Those are known as attributes. Okay. So if we think product is a table, so this is how we'll represent that product inside a rectangular box. A product can have a lot of attributes. We'll represent, let's say we have 3 attributes: PID, PName, and expiry date. So this is product ID, product name, and expiry date. So this is how we are going to represent those column headings or the attributes for a table. Okay. We can see that there is a distinction between these 3. The first one is underlined, the second and third one are not. Why it is underlined, I'll talk about that one later. But for the time being, understand that this Eclipse symbol that we have, that will be used for attribute, and rectangular box will be used for entity set or table. Okay, so once we have this entity, those entities will have a domain. What are the possible values of an entity? Okay, so possible values you can think of, if you're familiar with programming, then domain simply means the data type. Okay, although that doesn't cover everything that we will have in here, we can reduce the domain even further, but for the sake of simplicity, you can think of that one as a data type. Okay, so let's say you have the name as an attribute. So what will be the domain? We are expecting string or character, right, from the users that were going to use this one. So the domain, let's say we have marks for a student. In there, we are expecting integer or double, right? Floating point values 2.5, 10.6, things like that. So those are known as domain, the possible values of an attribute. Okay. Why I say that data type is not the only thing. Let's say we are talking about an attribute called gender, and in there we only want to store M or F or some other characters. Okay, so only some specific character, not everything. So if I simply say that the data type will be a character, then you can write anything from A to Z. But we might only allow M or F or any specific characters. Right? So that's what we can do. In the domain, we can only say that it will be of type character, but it will only allow M, F, or one of the characters. Okay. So that is what domain is. These attributes that we are going to make could be simple. Simple simply means that we will not be able to divide that one into multiple parts, or it could be composite attribute. Composite attribute means we can divide that attribute into multiple parts. Okay. So we first need to clarify composite. It will create some trouble later on. So let's say I have a table here like this. Okay, so let's say this is ID. Oh, sorry about that. Here I have name. I can divide this name into multiple parts, right? I can write first name and last name. So this is what composite attribute is. Okay, so if we can divide one attribute into multiple parts, that attribute is known as composite attribute. Okay, ID, or let's say student ID, we have a student table. So SID is simple attribute. We'll not be able to divide that one into multiple parts. But if we have name, the name we can divide into first name, last name, middle name. So that attribute is known as composite attribute. Any other attribute you can think of? Can anyone give me another example of a composite attribute that can be divided into multiple parts? Yes, someone is saying address. Good. So address we can divide it into multiple parts, definitely, right? Date of birth, yes, date of birth we can divide that one into day, month, and year. Excellent. Yep. So far we have got two: address, date of birth. Yep. So you got it. So when we simply can divide an attribute into multiple parts, that is known as the composite attribute. Next thing is single valued or multi-valued. Single value simply means in that attribute we can enter only one value, like your student ID. One student can have only one student ID. That attribute can be multi-valued as well. One attribute can have multiple values as well. Any example for multi-valued attribute you can think of? Two questions I can see. Someone is saying, why do you say in contrast to relational model? So when we learn about relational model next week, there we'll see that values will be simple only. Okay, but here we can see that values could be complex, like composite or multi-value. But when we learn about relational model next week, okay, so there we'll see that everything will be simple. Okay, so that's why it is written in contrast. Someone is saying, is composite meaning multi-valued? No. Composite means that we can divide it into multiple parts. The attribute we can divide into multiple parts, but multi-valued means same attribute but can have different values. Okay. So as an example, someone is saying orders a customer's placed. Okay. Name, person can have two name. You are thinking like that. Address, name equal to first name plus last name. No. So if you think about name equal to first name plus last name, that is a composite attribute. That is not a multi-valued attribute. Telephone number. Yes, one person can have, one student can have multiple phone numbers, right? One could be land phone, one could be mobile phone, things like that. Email address. Yes. Nationalities. Good examples. Hobbies. Yes. Now we got it. Courses enrolled. What courses he has enrolled? Yes. So one attribute which can have multiple values. Okay. So there's the difference between composite and multi-valued. Hopefully you got that one. Composite simply means we can divide that attribute into multiple parts. Multi-valued means we have only one attribute, but there we can enter multiple values. That is allowed. Okay. Next thing when we create attribute is to identify the keys. Okay. So we will learn about three types of key: super key, candidate key, and primary key. Okay. Super key, candidate key, and primary key. So let's talk about candidate key first. So candidate key simply means minimal set of attributes that can uniquely identify an entity in the set. When we have a table, in that table we'll try to figure out a set of attributes. Okay. Set of attributes. It doesn't say only one attribute. You might need more than one. Okay. So if it is only one attribute, that's fine. If more than one, that is fine, because this one is saying set of attributes that can uniquely identify, that is another important term, an entity in the set. And that set of attributes must be minimal. This is the most important word in here. Okay. So if that is minimal, at that time we will say that is a candidate key. Okay. So minimal set of attributes, we'll try to figure out some attributes that can uniquely identify an entity. So think about a table. In that table, we have different rows, right? So we need to figure out an attribute which can identify each of the rows uniquely. Okay. So think about student ID. So when we know an student ID, from there we can uniquely identify each of the students. Right? So that could be one candidate key. Again, phone number of a student, that will be unique, right? So using the phone number, we will be able to identify the student as well, or from the email address. Right? So those are the candidate keys. So for a student table, let's say we have student ID, phone number, email address. All three could be candidate key, right? From this candidate key, we will choose the one that we like the most. Okay, there is no specific rules to select a primary key. So among those three, those are known as candidate key. From the candidate key set, you can choose anything, okay, to declare that one as a primary key. Hopefully that is making sense. So in here, let's say I am choosing primary key as a student ID. So if I choose student ID as the primary key, we will denote that one by underlining that attribute. So that's why we had an underlining that product table. Okay. So primary key will be underlined in a table. So when we are going to now define any schema, an entity schema, how the entity will look like. So these are the things that we need to mention. First is the name, entity set name, that means the name of the table. Then we will describe the attributes, the name of the attributes, and then the domain of those attributes, and then the PK means primary key. Which one will be the primary key of an entity? Okay, so for every entity, there must be one primary key that we are going to define. Okay, so these three things that we have to define. to define any schema, the name of the table, the attributes of that table, and the primary key, and also we need to define the domain for those attributes that we're going to have. So if you understand primary key, try to figure out which one do you want to choose as a primary key in this table, in this staff table. Which one could be a primary key? Okay, everyone is saying staff ID or ID. That's good. Now I have to figure out what would be the candidate key. What are the candidate keys in this table? Someone is saying all of them. No. No. So a lot of people are saying name could be a candidate key. Can name be a candidate key? No, because two persons can have the same name. What about date of birth? Can date of birth be a candidate key? Name cannot be a candidate key. What about date of birth? No, two persons can have the same date of birth. So knowing the date of birth, we will not be able to identify a person uniquely. What about address? Can address be a primary key? Sorry, candidate key? No, because two staff can live in the same house, can have the same address, right? So the rest of the things that we have, staff ID, email, and phone number, those will be unique for each staff, right? Yeah, so these three, staff ID, these are CK, email is a CK, phone number is a CK. So these three things are candidate key. From these three things, whatever you choose, most of you choose this staff ID, so that would be a primary key. If someone chooses this email, that's fine as well. Okay, we should stay. Hopefully making sense. Someone is saying are not candidate key and primary key the same? Yes, there is a simple difference, is that primary key is the one that we choose as the identifier. Okay, who can identify? So think about an election for president. Okay, so a lot of people submit their nomination. From there, only one person becomes the president. Right? So that's what primary keys. Okay, that one was easy. Which one will be primary key in this table? I wanted to figure out a primary key in this table. Most of you are saying house number. Think again. Just knowing house number, let's say the house number is 10. Can you identify a house? Because I have a street, in two different streets, there will be house number 10. Right? So simply knowing house number, can you identify uniquely a house? Someone is saying, what is suburb? What is built-in? Built-in simply means when that house was built. Okay, so built in which year? That's what that will represent. Suburb simply means, how do you say that? Part of an state. Okay, so like Paramada is in suburb. We have university at Darlington. Darlington is a suburb. Okay. Yes, so I can see varying answers. Some people are saying first two, some people are saying first four. Yep. Someone is saying all of them, someone is saying none of them, create a new ID. Yep, that is another option. Yes. Someone is saying the other slide said one of the candidates key is chosen as the primary key. How does that work for this? So if we have only one candidate key, then that will be the primary key. We don't have to make any choice, right? Only when we have multiple candidate key, at that time we need to make a choice. Okay, so in this case, yes, so all of you got it right that house number alone cannot be the primary key, right? So just knowing the house number will not be able to figure out which house it is if you don't know the street name. Okay, so again, if we know the street name, now if you assume that two suburbs can have the same street name, okay, then just house number and street name will not be enough if two suburbs can have the same street name, which is possible. Okay, so we'll extend to suburb. Now, if we still assume that in an state there will be two suburbs with the same name, and then there will be two streets with the same name, then there will be two houses with the same number, which is quite possible. Then you need to include a state as well. Okay. But I'm guessing in an state there will be no two suburbs, which will be of the same name. So that's why I'm saying house number, street name, and suburb will be primary key in this case. Okay, but in your specification, if it is written that one state can have multiple suburbs with the same name, at that time you need to extend that one till suburb. Okay, so depending on this specification, you need to define your primary key. Okay, so all of these will create one primary key. So each table can have only one primary key. So this is the candidate key, and since I have only one candidate key, so that one will be the primary key as well. Okay, hopefully making sense. Few people suggested that we can create another attribute. Yes, that's what you can do as well. So, but remember, whenever you are creating one attribute, you need to store some information. That means you are taking more memory, right? Yep. So if you want to create, let's say, a house unique ID, that's what you can do for each house, but that will take more memory, right? But yet, that is an option. Someone is saying, can one entry have multiple primary keys? No, there will be only one primary key. Okay, in a table, it can have multiple candidate keys. Like someone is saying multiple email address or phone number for one person. So here we are not talking about the data, right? We are talking about the attribute. Which attribute is the primary key? In that attribute, we can have multiple data. One person can have two email addresses, but using either of those email addresses, you can figure out which that person is. Okay. Someone is saying, is CK only minimal set of attributes? Yes. So candidate key, the definition says it should be minimal. Okay. So if it is not minimal, only set of candidates that uniquely identifies an entity in the set, that will be a super key. Later we'll learn. When it is minimal, at that time we say that that is a candidate key. Hopefully things are making sense, how to identify a key. So that is the first thing that we are going to do. First, we create a table, and there we'll figure out what should be the primary key in this case. Okay, so now we have some idea. So let's put all of this together and let's see how this looks like. So this is what we have learned so far. An entity set is represented by a rectangle. Attributes are represented by ellipse, and keys will be underlined. Okay, so if I have a primary key, then I will underline that one. And I must have to have a primary key for each table. So in here we can see this image. Here we have a simple difference is here we have double eclipse. What does double eclipse means? It simply means there is a multi-valued attribute. This attribute can have multiple values. Okay. So book, author, in a book there can be multiple authors. Okay, so 2 or 3 authors. So you can put all of them in here. Okay, so if we have a multi-valued attribute, that is how we are going to represent them using double eclipse. Okay. Hopefully making sense. Someone is saying, what is ISBN of a book? So that is an international keyword, okay, so which uniquely identifies each book. So whenever you have a book, on the top of a book, you will find an ISBN number. Okay, international standard for books. Okay. Okay, we can have, let's say, another table called employee. Okay, so in the employee table, here we can see one new thing is this dotted eclipse. The dotted eclipse means derived attribute. So derived attribute means that the value of this attribute will be calculated from one of or set of existing attributes. Okay, so like we want to derive the age of a person and we want to store that one in the database, so we can derive that one from the date of birth that person has entered. So in the form, we will not ask what is your database and what is your age. We'll simply ask for his date of birth, and from there, if we want to store something, okay, for the ease of calculation later, we can do that, and that one is known as derived attribute. Okay. Someone is asking, multi-value is for the same entity? Yes. So for one book, we can have multiple authors. Right? So that is only one entity. So we can have multiple authors. That's why this one is represented using double eclipse. So hopefully this derived attributes is making sense as well. What I want to do is have a look into this image. Okay. Try to figure out what is it that this one represents. If you have any question, feel free to ask. Try to figure out the primary key, the table, the composite attribute, the multi-valued attribute, all of those things. Someone is asking why age is different. Can someone else answer? Write in the chat box. Why age is different? Because that is a derived attribute, right? It is related to date of birth. From the date of birth, we will calculate age. So that's why that is derived. Someone is asking, why does phone number have double eclipse? Any answer from the audience? Why does phone number have double eclipse? Yes. So that represents that one customer can have multiple phone numbers. Excellent. Okay, so let me throw one question. What are the composite attribute in this customer table? Which one are the composite attribute in this customer table? Yes, some of you are only saying name and address. You are missing one. Street. Street is also a composite attribute, right? So in this case, we have three: name, street, and address. Right? So name, street, and address, these three are composite attribute, hopefully making sense. This one is the PK. This is multi-valued. This is derived. Okay, and that's it. Okay, hopefully things are now making some sort of sense. So now we have an idea about creating a table. So we now know everything how to create a table. That's great. Next thing, so we learned about entity. The diagram name was entity relationship diagram. So we simply now need to understand about relationship. If we understand that, then we can create the whole thing. So this is what we have learned. How can we create student and course? Okay, so if we have two tables, student and course, for the sake of simplicity, I didn't show all the attributes in here so that I can focus on relationship. Okay, but assume there are attributes in student table and course table. Okay, so this is what now we are going to focus on, is that now we have two tables. One, let's say student, another one is course. So in this table, we have student information, here we have course information. Now we need to combine or relate these two tables, right? That one student is enrolled in one course. So how will we represent that sort of relationship? From this figure, you have already figured this one out, hopefully. The relationship will be represented by this diamond shape. So this diamond shape represents the relationship between student table and course table. So this relationship could be of different degree. It could be unary. It could be binary. Binary is what should make more sense. That is student table, EOS, unit of study table, and we have an enroll table. We also can have ternary relationship. Let's go one by one. What is unary relationship? So employee manages employee. So in the employee table, I have one employee, special type of employee, right, who is a manager. So do I want to store manager information in the different table? Probably not, because manager is also an employee, right? So we will have all the employees information in the employee table. That means including the manager. So in this case, one manager or one employee manages all the other employees. Let's say, or some employees manages other employees. So that's why we have a relation with the employee table and employee table. So employee manages employee. Okay. Can anyone think of any other example for unary relation where we might need unary relation? So this is one, employee manages employee. Anything else you can think of? Someone is asking, is entity set basically a table? Yes. Next week we will learn that entity set is nothing but simply a table. Okay, anyone, anything you can think of for where you might need unary relationship? Lecturer teaches students, no? Lecturer is a separate entity, student is a separate entity, right? Lecturer is not a student. So that will be a binary relationship. Mom and children, how? So if we are thinking mom and children, everything is person, we'll insert every person's information in one table. Yes, then that is possible. Anything else? A person lives with another person, so all the person's information will be there. Student teach students, peer help program. Yes. So think about tutors. Your tutors will be students, right? So who are teaching you. So tutor manages students, right? So tutor is also a student. Think about again a team. Okay, so in a team you can have captain, right? So you can have players, right? So players manages players, right? So you have one player who is the captain who manages all the other players, right? That could be one. Student manages student, someone said, where that special student could be a tutor, right? So termed as a tutor, those sort of things. Hopefully making sense when we need unary relationship. Next one is binary, should make sense. Okay. And then ternary relationship. What does ternary relationship mean? Ternary relationship means that we can connect three tables at the same time. Okay, so here we have vendor, warehouse, and part. So one vendor is sending a part from this warehouse, or one vendor ships one part of a machine from this warehouse. Okay. So here we have this relationship. Okay, so that's why we have diamond. I can see that someone is asking why some are diamond, some are square. So this means these are table, and this one means that they are relationship between these two tables. Okay, so in here we have this ships table, which is the relationship between vendor, parts, and warehouse. Okay. Someone is asking, in unary, diamond is a subset of a square. Not actually subset. Next week we will learn how we'll represent that one as a separate table if needed. Okay, or if needed, we can create that one as a subset. Okay. So depending on the specification, we can do both for the unary relationship. So for the time being, don't worry how we'll convert all of this into table. That's what we're going to learn next week. Okay, so next week we'll exactly learn, we'll have something like this, how to convert it into actual tables. Okay, so for the time being today, we are learning these symbols, how to represent this relationship. Hopefully this thing is making sense. We can have unary, binary means 2, and we can also have ternary relationship. Okay. Yep, someone is saying still some confusion regarding the unary relationship. So employee table, you have employee table, there you have all the employee information, right? One employee, this particular employee will be termed as a manager. Okay. So for that one, let's say we will have an attribute, manager or not. For yes, 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 no, 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 you will simply include in that attribute. Okay, if someone is a manager, we will simply say yes. If not, then if for everyone else, that will be no. Okay, you can think something like that, and that will be an unary relationship. We are saying employee manages one employee. Relationship attribute. What should be the attribute of that relationship that we are looking into, right? So let me show you this one. Let me go back to the previous slide here. So the attribute of this enrolled table, first of all, so we are trying to connect, right? So we are trying to connect the student and unit of study table together. So what attribute can we take from in here and in here so that we can make a connection? But we know that this student is enrolled into this unit of study. So student A is enrolled in C1, course 1. Okay. So which attribute should I take into this enrolled table? Definitely the primary key. That's why we created the primary key, because primary key can uniquely identify every other attribute. So if we simply take the primary key of student table into this enrolled table, and also the primary key of unit of study table in here, right? So in this enrolled table, we will have, let's say, student ID, and from unit of study table, let's say we will have course code. Okay. So we know in student ID, we know course code. If we simply put all this together in this enroll table, then we can connect these two tables, right? From student ID, we can figure out the student's name, his address, phone number, email address, everything. From course code, we can identify what is the credit point of that unit, which semester that has been offered, who is teaching that course. So all the information we can figure out, right? So only thing that we need to take is the primary key from student table and the primary key from unit of study table. So this enroll table or the relationship table that we are going to make, like in this case ships, in this case manages. So in there, we will simply put the student ID and the course ID. Okay. For unary one, what will happen? Again, think about the example that I showed before, that this person is a manager. That's fine. Yes, he is a manager. Next question comes, he is a manager of whom? He might not manage all the other employees. There could be a specific set of employees that he manages. So we need to store that information somewhere, right? So that's what we are going to store in here. In managers table, we'll store he is the manager and he manages these sort of employees. Okay, so that is what we are going to include in here. Okay? So main thing is that in the relationship table, we will simply take the primary key of these actual entities that we are trying to connect. Hopefully that thing is making sense. Okay. Relationship set, or this relationship that we are going to create, it can have its own attributes as well. So first I said that the primary key will come, so that will always be there. Okay. Also, this one can have its own attribute. Okay. So let's say, think about this one. Academic staff teaches the subject. In which year? Based on year, the lecturer might be different, right? So these teachers can have one attributes of its own, which is year. Okay. So how many attributes do I have in this teachers table now? Definitely 3. One coming from here, the primary key, another coming from the subject, the primary key, and another one is this year. Okay. Hopefully that thing is making sense. If not, feel free to ask. Someone is asking, sorry, what manager diamond just stored? So if you have a unary relation, right? So what will we store in this manager table? Anyone? This is employee table where the primary key is, let's say, employee ID. And here you have this manager table. So here you have employee ID, employee name, phone number, address, all the things. In manager table, what will you store? Definitely employee ID and employee ID. Now that one might be confusing. So we'll change this one to manager ID. Okay. So a employee which is a manager. So that employee ID will be here. Let's say 01, 02, where 02 manager 01. So what we will write? We'll simply write manager ID 02, employee ID 01. So 02 is the manager and he manages 01, this employee. Okay. Someone is asking, is it to link tables in SQL? Yes. We will link tables in SQL like this. Why the academic staff can be one attribute of teachers? No, got it wrong. So from the academic staff, we will bring the primary key. From the subject, we will bring the primary key again into this teachers table. This is another table, simply a table. Okay. So in this table, we are trying to connect these two actual tables. And in this teachers table, we can also have year. So let me write all the things, then probably will make sense. So in the academic staff, let's say I have name of the academic staff is designation. Okay. Is a lecturer or something like that. So this is one table. I have a subject table. In the subject table, I have subject code and subject name. So this is our subject table, right? So now we are trying to connect these two. So we are trying to connect these two using this teachers table. So what this teachers table will have, so let's say in this case, name is the primary key. Although two persons have the same name, but for the sake of simplicity, let's assume that name is the primary key in this table. So we'll bring the name of the academic staff from here. This is the name. And then we'll take the code from this subject table, right? So now we have name and code of the subject that this academic staff teaches this course. Now you might want to store another information is in which year he teaches that one. So that is what I'm saying, that in here we will then have another attribute which is known as year. Okay. Hopefully now things are making more sense. Someone is asking, why don't you include year in diamond? Yes, year is included in the diamond shape. Okay, so now next thing that we need to figure out is that what will be the key for the relationship table. This relationship table that we have created. Now we know the primary key is coming from a student, the primary key is coming from course. What will be the key for this table? Because in each table we need to define one key. Okay. So in enrolls table, what attribute do I have? Looking into this too, I have SID and I will have CID. Does anyone have any idea what will be the primary key for enroll table? In student table, student ID is the primary key, you can see that is underlined. In the course table, course ID is the primary key that is underlined. In enroll table, when we actually create, which one will be the primary key? Someone is saying CID. So knowing the CID, can you uniquely identify each student? Let's say SID is 101 and CID is C01. How the data will look like? Another student 102 who is also in C01, right? I have C02, sorry, and I have student 101. Which one can be the primary key? Yes, so most of you got it right now. That combination of both. Just knowing student ID, I cannot immediately identify because here I can see 101 and 101 again. So from 101, I can, this time I'm getting C01, but using 101, I'm getting C02. Right? So what do we have to do? We have to take both of these to create a primary key. Okay, hopefully making sense. So that is what is written here, that student ID and course ID will be the super key of this enroll table. Okay, from that super key, we'll ultimately say that that will be the primary key. Okay, when we are trying to define the primary keys, okay, we need to have a look on the relationship as well. So relationship simply means that when we are trying to connect two tables, what is the type of relationship that we have? Okay. So relationship simply means that how they will be connected. So for that, if you remember elementary mathematics, there we learned about relation. Okay. So think about, we have two sets. Set A is 1 to 3, B represents A, B, C, D. Okay. So if we take the cross products will give me all of these elements. Okay. And a relationship simply is a subset of this cross product that we can have. So in this case, what can we see? So we can see that 1 is connected with A, 2 is connected with C and D, 3 is connected with B. So what is the degree of relationship in here? So in here, degree of relationship, we know 4 types of degrees: 1 to 1, 1 to many, many to 1, many to many. Okay. So what is the type of relationship that we have in here? That's what we have to figure out. If the relationship look like this, then this is a many to many relation. Can anyone think of any example where that is a many to many relation? Let me show you the first one, then you can figure out probably the next one. So let's see student table and course table. So one student can take multiple courses and one course can have multiple students. Hopefully making sense. So that is a many to many relation. So this one is represented here, that one student can be enrolled in 2 courses. One course can have 2 students. So that simply means multiple. Okay. When we have more than one, that is known as multiple. So student table and course table, the relationship between them is many to many. Another relationship possible is 1 to many. Any example comes to mind? Or 1 to many? Which one should I write in this and in on the right hand side? Someone is saying phone number. Again, phone number is an attribute, not table. We are talking about table. Okay. Someone is saying teacher and student, state to people, user and phone, book and that part is missing, customer and order, author, people and pets, book and authors. Okay, a lot of examples are coming up now. Now probably you got that. Okay, so let's say I'm using that one is teacher and course. So one teacher can teach multiple courses, but in one course there will be only one teacher, right? So one teacher can teach multiple courses. So one teacher is teaching 2 courses in this case, but for each course there will be only one, let's say, teacher or coordinator. Okay. Hopefully you got that. Next one is many to one. Any examples for many to one? Student course, no, student course is many to many. because one student can take multiple courses. In one course, we might have multiple students. Orders, customers, child to parent, class to student, employee to company. Yep, someone is asking simple question, how is one to many different from many to one? Yes. So in this case, I had teacher on this side, course in this side. If I simply change that one, so in here, if I put course and in here, if I put teacher, that will be many to one, right? One teacher can teach multiple courses. In one course, we will have only one teacher. But a lot of you have given a lot of other examples as well. Last one is one-to-one. That should be pretty easy. Any example for one-to-one? Husband, wife, student ID. Again, student ID is the attribute, not a table. Okay. Social security number. Again, those are attributes. If you are not storing any other information other than the ID or social security number, then no. Someone said passport. If you are storing a lot of information for passport, like the nationality, the date of issue, then yes. One country has one capital. Okay. I will say like this. Let's say team and captain. Okay. So this would be a one-to-one relation. In one team, there will be one captain, and one captain only manages only one team. Right? Yep. Username, password, car, engine, marriage, registration. Yes. So you got that one. That's great. So these are the 4 types of relationship that is possible. Okay. Hopefully you got that one. Do we have to create a super key in a diamond? No, we can have, we only have to create the primary key, okay, not the super key. Someone is saying one team can have 2 captains. No, there will be some vice captains, that is possible, but only one captain. Only when the captain is not present in the field, at that time someone might act as captain. Okay, but probably we got the idea. That is the main thing. Okay, so now we have idea about this relationship. How we'll represent all of this? Okay, so let's say I have this relationship which is saying at most one. Okay, so at most one simply means, let's say this one is saying that an employee works in at most one department. What does that mean? So that means that employee can work in at most one or no as well. So employee works in 0 or only one department. How 0 is possible? For the sake of understanding, think about this: a new employee who has not assigned to any department yet. So that is what at most one represents. That employee can be assigned to at most one department. How will we represent that one? We will represent that one using arrow. Okay. So this arrow is the one that we are going to use to represent at most one. Okay. Someone is saying, can we take a short break? After 5 minutes, we'll take the break. Okay. Let me finish this 4th type of thing. How do we represent? Then we'll take a break. Okay, so if this one is saying an employee works in at most one department, so at most we'll represent that one using this arrow. Okay. At least, if this one is saying at least one employee works in at least one department, that means that he can work in multiple departments as well. Okay, so if that is the case, then that thing will represent using thick line. You can see that this one is thicker than the normal one. So in this case, that is represented as at least. Hopefully making sense. Someone is asking, can employee work in 0 department? Like I said, think about a new employee who has not been assigned to any department yet. So at that time, we will simply insert the employee information, but no department information for the employee. Right? So at least will represent using thick line. So at least means minimum 1, maximum no bound. Okay. Exactly 1. Exactly 1 simply means that we have at least and at most, right? So exactly 1. So at most is saying 0 or 1. At least is saying 1 to more, right? So when we have both of them, that simply means 1, right? So both of them simply means we have arrow and the thick. And then we'll say that that is exactly 1. So exactly 1, every employee works in exactly 1 department. Okay. So this is how we are going to represent in this case. Someone is asking, what does ER stand for? E means entity, R means relationship. Okay. So these are the entities, employee and department. R is the relationship which is works in this case. Right. So 3 things I tried to explain. First one is at most 1. We'll represent that one using arrow. At least 1 will represent that one using thick line. Exactly 1 will represent that one using thick arrow and thick arrow. So that will be thick and there will be an arrow. Okay, so that is exactly 1. What is the difference between at most 1 and exactly 1? Yes, so at most 1 means that it can be 0 as well. Okay, so think about one teacher is assigned to courses, teacher and course table. There could be a teacher who has not assigned to any courses yet, or probably he is simply a researcher. Okay. So he has not been assigned to any courses yet, or he can be of at most 1 course can be assigned to him. Okay. So at most means 0 and 1, and exactly 1 means that exactly 1. Right? You must be assigned to 1 department. Okay. Cardinality constraint simply means that before we learned about at most, exactly, and at least, but if we want to limit the maximum number or the minimum number, we can do that. So when we learned about at least 1, then I said from 1 to any number, right? But if I want to limit that 1 employee can be employed in 1 to 3 department, maximum 3 department can he be employed. Okay, so we can write that on as 1.3. For 1 department, how many employees there can be, I can limit that one. If I write 0 dash star, that simply means no employee or a lot of employees. Star simply means maximum number we can think of or don't care. Okay, so it can have no employees. When the department is started, probably there was no employee. Later, the employee number grows. Or if you want to limit that in a department, there can be only 50 employees, let's say maximum 50. This is how we are going to write. Okay. So probably I have talked a lot. Take a break. We'll take a break of 3 minutes. When you come back, I want to take the poll. Not now. Definitely take a break. Okay. And then when we come back, we will talk more. I've opened the poll. When you come back, drink some water, have a walk. I need to open up the question page as well. Hopefully you can see both of those now. Okay. Some question there. What is the difference between participation and key constraint? Yep. So participation simply means how much participation is there. Is it total or partial? Okay. Oh, sorry. I've opened up the wrong poll. Sorry about that. I should have opened up this one. Yep. Week 2 is in progress now. And key constraint simply means primary key, candidate key, and super key. Okay. Unary relationship, when we are connecting the same table with the same table, like employee manages another employees, that's where we create unary relationship. Okay, so we'll take break of 2 minutes and then I will answer other questions. Okay, so take a break. Okay, I'm back. Hopefully everyone is back too. The poll is going. Good. I'll give you 30 more seconds, then I'll stop the poll. Okay, that's good. I'll end the poll now. Let me share the result with you. Hopefully everyone can see the result. Okay, the first one, we have an arrow in here, right? So if each athlete can run in at most one race, yes. So arrow represents at most one. That's great. Next one is person likes color. We have on this side. So each color is liked by at least one person. Yes, most of you got it right. 64%. Still 39% people said the last one. Each person must like at least one. No, the thick line is on this side, right? So you have to read it from this side that each color must be liked by at least 1%. Child, so here we have a thick line and an arrow, so this one will be exactly one. So each child will own exactly one pet. Someone is asking, why do you read it that way? Because the thick arrow is on this side, right? Because if the thick arrow is on this side, then we'll, so this one is saying, if I read it from this side, this simply means many, right? So one person likes many color, but on this side, this one is saying each color is liked by at least one person. Okay, so depending on which side the arrow is, right? So on both sides we can have arrows, things like that. How to distinguish relationship between each and every? So that depends on the participation. Okay, so in this case, each and every means the same thing for the time being. Later, when we learn about participations, there we'll see some differences. Okay, but in this case, each and every means same. Okay, what is the correct model for question 4? Okay, so there is no actually correct answer for question 4. It depends on the specification. But think about what do you want in an employee and project relationship, right? So the first one, what is the first one saying? So first one is saying that each employee manages at most one project, and this part is saying that each project is managed by at least one employee. Depending on the specification, that could be true. So you can have this one. Now probably you can understand all of this. Can anyone write number D? What does number D represent? That's what I can see that most of you have chosen as the answer. So what does that relationship represent? Okay, like each employee manages how many projects, or each project manages how many employees. If we try to translate it into English sentence, what will be that sentence for number D? Yes, I got two answers. Each project are managed by at least one employee. Yes, each project must be managed by at least one employee. Project is managed by at least one employee. Yes, so you got it now, right? Okay, so that depends on the specification that you will have. Okay, and based on that, you will choose one of the four. Hopefully, things are making sense. Stop this poll. Someone was asking about unary relationship, participation, and key constraints. So participation simply means these four relations that we have learned, whether it is one-to-one, one-to-many, many-to-one, or many-to-many in this case. Okay. And unary simply means whether we are connecting one table or more than one table. Okay. So if we are connecting only one table with this one, that one will be a unary relationship. Otherwise, depending on the number of tables, it could be binary or ternary. Okay. Okay. So far, whatever we have learned, okay, that is the main model that Chan has proposed. Later, people made some improvement on that model, okay, and that is known as the enhanced model that we have. Few questions are there. I think B is the same as C. Was B and C same? Have a look. No, B and C are not the same. We have an arrow in here. In this case, we don't have an arrow. So there is a difference. So this one is saying one employee can manage at most one. In this case, this one is saying one employee can manage many projects. Okay, so there is a difference between B and C. What is the answer for 4? Like I said, there is no correct answer. It depends on the specification. Okay, so depending on the specification, you will choose either of these 4. Someone asked, I saw a question that in the ER diagram for the assignment, can we use different notation style like cross-foot model? No. You can only use the notations that I have shown you, which is chance model. Okay, there are lots and lots of ER model available, okay, so that there is no confusion there. I will mention this one at the end as well. Okay, so this is the only notations that I have shown you. This is the only one that you can use for your assignment and also for your final exam. Someone is saying participation could be many to many or many to one. Yes, so depending on what sort of table you are connecting, right? So that is what we can figure out from there. This total participation or partial participation, I'll talk that one later in the enhanced model. Okay, there I'll try to explain. That's why I'm not showing this one, but later I will explain what does total and partial means. Okay, let me move on. Advanced features that we have in the change model. First one is weak entity. The tables that we have created so far, we will term that one just to match the name is a strong entity. Okay, student, course, all of those are strong. So which one will be a weak entity? So an entity that does not have a self-contained primary key, that table will be known as a weak table. Okay, if any of the attributes that we have in that table cannot uniquely identify all the attributes because it is dependent on another one. Okay, someone is asking what if both sides are just thin lines? That simply means many to many. Okay, thin line simply means many. So if both on side you have thin lines, that simply means many to many. Okay. Weak entity type, when we don't have any self-contained primary key, that simply means one table which is dependent on another table. If that is the case, that table will be known as the weak table. Okay. So weak table simply can think of a part of relationship and it depends on an identifying table. Okay. Like payment of a loan. Let's say you have a table where you are storing payment and you have loan table somewhere else. So these are two different tables. One is loan table, another one is payment table, right? So now you are making a payment. So payment number P01 on this date, August, and you paid $500, right? So definitely you need to know for which loan you made this payment. Right? So this payment must be related to some loan, because in a loan, if the loan is, let's say 10,000, he has paid already 500, then some calculation need to be there. So this payment must be related to a loan, right? So that's when this payment table will be termed as a weak table, because this payment table, whenever we try to insert some information here, we need to know the loan number, right? For this one. So that is what weak entity means, when one table is dependent on another table, like in this case, payment is dependent on loan. At that time, payment will be known as a weak entity. Okay. And in this payment table, we might have one attribute. Okay. So which can uniquely identify all the other attributes, and that one will be known as partial key or discriminator. Okay, not the primary key. To form the primary key, we need to add the loan numbers primary key plus the partial key from the weak entity that we're going to have. Okay, this was written here. Primary key of a weak table is formed by the primary key of the strong entity on which the weak entity is dependent plus the weak entity types discriminator. Okay, so if I have payment table and loan table, what will be the primary key of payment table? loan number plus, let's say, a payment ID I have. Okay. Someone is saying exclusive. What does exclusive part means? That simply means that this payment table actually a part of this table. Okay, so it will always be a part of another table. So this is how we are going to represent a weak entity set or weak table using double rectangle. So when we use double rectangle, that one represents a weak entity set. The relationship also be weak, and that's why we have this double diamond shape. Okay, and the relationship between strong entity and weak entity will always be like this. What does this mean? Is this many to many, many to one, one to many, or one to one? What does this one represents? Someone is saying one to one. Is that right? No. One to many. What is the degree of relationship in this case? Yes, one to many, right? So whoever said one to many, all right, right? So like one loan can have multiple payments, but for each payment there must be or exactly one loan. So this is what it represents, right? So this one represents exactly one. So for each entity there will be an exactly one loan. So this is how we can understand now. Loan has payment. In the payment we can have payment number, but there is a discriminator or a partial key that we show as an dashed underline. Okay, so to create a primary key for this payment table, we need to add loan number and also this payment number. We will add to create the primary key for this payment table. Okay, hopefully making sense. Someone is saying, why not many to one from the right hand side? We always read from left hand side. Okay? So we always read from left hand side. So this is what we will say, that one to many. Someone is saying, why one to many? Because one loan can have multiple payments, but for each payment there will be only one loan. Someone is saying, but the right has a thick line. You said read the right thick line before. Yes, read the thick line, that's fine. But if you read the thick line, that's what I'm not asking. Think about what is it that I'm asking. When you read the thick line, at that time you are simply reading, right? So you are simply reading exactly or at least or at most. But that is not what I asked. I asked for the relationship degree. Is it many to many? Right? Is it one to many? Is it one to one? Or is it many to one? That is what I'm asking, right? So we need to have a look into both sides, from left to right and also from right to left. Hopefully that is making sense. This is when I am trying to convert this one into a specification or in a statement, right? So at that time, we'll simply read this one, that one payment will have exactly one loan. Each payment will have exactly one loan. Hopefully making sense. Okay, so that is one advanced feature, weak entity set we can represent. Another one is specialization or generalization, and finally we'll learn about aggregation. Okay, probably for weak entity set, just to confirm that you understand it better, can anyone think of any other example which would be a weak entity we have to represent as a weak entity set? So this is one, payment of a loan. Any other example comes to mind which we might have to represent as a weak table? School to student with parents. Okay, yep. Customer borrows a book from the library. Okay. Customer and payment. a gift of merchandise. Yep, varying examples we can see. I will use the first one that someone said student with their parent. Yep. So think about, we have a student table in a school. Someone said we have a student table and we have their parent table. Right. So the parent information that we have in here must have one student associated with that one. Right? If that student is no longer in the school, then we simply need to delete that information from parent table as well. Right? So let's say student ID is 01 and their parent information is here as well, E01. If this student is no longer a student of this school, what do we have to do? When we remove this student information, we have to remove the information from here as well. We can think like that, right? So that's why you can see that parent table is totally dependent on the student table. So parent table will be a weak entity in this case. Excellent example, whoever said that one. Hopefully things are making some sense. In the tutorial, you will have some other examples and there we will practice all of these things that we are learning today, okay? Okay, next two things, these are the last two things that we are going to learn, is specialization or generalization and aggregation. Okay, before I move to specialization and generalization, do I have that image in here? Let me just check. No. Okay. For specialization and generalization, let me first draw a picture and probably then it will be easier for me to explain. If you are familiar with object-oriented programming or Java, then you know this thing. Okay. Otherwise, this might be new. I don't know why my pen does that. Okay. Think about a relationship like this. I have a table which is animal, and I also have dog and cat. Okay. Dog is definitely an animal. Cat is definitely an animal. So since dog and cat both are animal, they might have some common attributes. Right? So all of those common attributes that we will have for all of these animals, dog, cat, bird, horse, everything that we can think of, do we want to store them separately in each table, or do we want to store them only one table? If we store all the attributes like dog's name, their age, those sort of thing, or cat's name, cat's age, those will be common attributes. We want to store them in one table, which is, let's say, animal table. Okay. At that time, this generalization and specialization things come into effect. If you are familiar with any object-oriented language like Java, okay, so this is what we call superclass or parent class, and these are called as subclass or child class. Okay, if you are not familiar with those, don't worry about those terms. Simply think that this is a relationship. This is what is written here. So generalization or specialization or inheritance in terms of Java comes into effect when we have an is a relationship. F is a E. In this case, dog is a animal. Cat is a animal, right? So when we only have that sort of thing, at that time, these specialization generalization things come into effect. Okay. Like student is a subclass of person. So each student is a person. You can have teacher. Teacher is also a person. Staff member, they could be person, right? They could be, they will be person. So when we have this sort of hierarchical structure, at that time we think about generalization and specialization. How do we represent this sort of connection between tables? Using is a, we'll write use a inside a triangle. Okay, very simple. Have a look, should make some sense. We have person table, we have employee table and customer table. Employee and customer, definitely a person. So an employee will have employee ID, employee name, street, and city. A customer will also have a customer ID, customer name, street, and city. So all of these four attributes, if you want, you can store them separately in employee table or customer table, that's fine. But if we want to store them in a separate table, at that time the relationship will look like this. Okay. So in person table, we will only have the common attributes, ID, name, street, city. If we have some different attributes, that we'll put in that respective table. Like in employee table, we might have a salary. We cannot put that in person because every person will not have a salary. Only the employees will have salary. So that attribute will put into employee table. A customer, we might have credit rating, how much he spends, how much he takes loans from a bank. Depending on that, he might have a credit rating. That attribute we can put into this customer. Just looking into this picture, we can definitely identify that employee table have ID, name, street, city, and salary. Right? Customer table also have ID, name, street, city, and credit. Only thing is, these common attributes, we are putting them into one. Okay? If this is the structure that we are going to follow, then we have to use this is a relationship. Okay? Employee is a person, customer is a person. Okay. Again, same thing is in here. Officer is an employee. So an employee can be divided into multiple categories, right? Multiple designations. They could be officer, they could be tailor, they could be secretary. So each officer will have their salary, their ID, their name, street, city. Each tailor will have their salary, ID, name, street, and city, right? So all of the things that we have on top of that will come in. Tailor might have their own attributes, secretary might have their own attributes as well. Okay, hopefully things are making some sense. Someone is asking, but a person also has a salary and a credit rating. So you are thinking about a person who can be an employee and a customer. Yes, that is what we are going to learn next in this covering constraint. I'll go there later. But before that, let me show one more thing. Overlapping constraint or not. Overlapping simply means an entity can belong to only one lower level entity set. Okay. An entity can belong to only one lower level entity set. If that is the case, we will say that is disjoint. If that is not the case, that an entity can belong to more than one lower level entity set, then we will say this one is overlapping and this is default. That means if you don't do anything, then this is overlapping. And if it is disjoint, you have to write disjoint. Okay, you are by writing disjoint next to the is a triangle. I'll show that one, no worries. So think about which one could be a disjoint and overlapping in this is a. We have two is a, this one and this one. What do you think? Which one could be disjoint? Which one is overlapping? Both of them are overlapping because I have not written anything, right? But I can change one into a disjoint. Which one could be that one? First one is overlapping. Yes, because someone already gave us some clue that one person can be an employee and a customer. Think about a bank employee. The person is a person, he is an employee at that bank and also he has an account in that bank. So a person, he is an employee and he is a customer. But think about this one. An employee cannot be more than in one places or one designations, right? He can either be an officer, either can be a tailor, or can be a secretary. So at that time in here, we will write disjoint. Hopefully that is making sense. Okay, in here, we'll write disjoint. So disjoint simply means that employee will either be an officer or a tailor or a secretary. He cannot be in more than one role at the same time. Someone is saying you need to explicitly write disjoint, but no need for overlap. Yes, that's what he's saying here. So you need to write disjoint. For overlapping, that is by default. Okay, so you don't need to write. If you don't write anything, we'll always know that is overlapping. If it is disjoint, you have to write disjoint. Is there any acceptable shorthand way of writing disjoint? Unfortunately, no. We have to write disjoint next to an is the triangle. Okay. Someone is asking, a lower level entity type has more attribute than its super type. Yes, it can have more than its super type. That's fine. Okay. If you have some extra attributes, at that time you will have more, right? But it can have other attributes. So there is no relation between that thing. right? Employee can have many other attributes, and officer will have all of those attributes plus some attributes. So the normal thing is these are child. The child gets everything from parent plus adds something of his own attributes. Okay. Hopefully that thing is making sense. Covering. This is where this total and partial comes. Previously we seen this total and partial. Okay, this is where I tried to explain. So total means an entity must belong to one of the lower level entity set. If that is the case, we have to write a thick line. Partial means an entity need not belong to one of the lower level entities. This is default. So if I don't write anything, then that is partial. If I draw a thick line between the is a triangle and the superclass, then that will be total. Okay. Again, among these two is a, which one can be total, which one can be partial? Any idea? Can this be a thick line or can this be a thick line? Again, if you miss that part, total means an entity must belong to one of the lower levels. Say. Partial means an entity does not need to belong in any of the lower levels. Say. Okay. Yes, excellent. You got that one right. Most of you got that one right. Each person might not be an employee or customer. We can save arbitrary person's information, right? Who are not employee, who are not customer. But if we have an employee, right, we want them either to be an officer, tailor, or secretary in either of these roles, right? So in that case, what do we have to do? We have to draw a thick line in here. Remember, why do you have to draw the thick line? The thick line is between is a and employee. Okay. If you do that, someone is saying employee can be of other occupations. If that is the case, then we will put all of those occupations in here, right? Because if we simply create another table in here, we don't have anything, any connection in this diagram, then at that table we have to store ID, name, street, city, salary, and every information again. Someone is asking about the software. Just hold that thought. I'll show you. Okay. What is the answer? Answer is this. This one will be a thick line. That is the answer. Okay, and this one will be a normal line. Okay. I'll talk about the software later. Don't worry. Okay. I'll show you as well. Last thing that we want to know is aggregation. Aggregation simply means aggregate a lot of things into one. Okay. When we have some situation that we cannot represent that using the things that we have learned, we will try to aggregate. Okay. So in this case, let's say we have a ternary relation, project, department, and employee. So each project can be sponsored by one or more department. Hopefully that thing is making sense, because I have a thick line in here. Thick line simply means at least one, right? A department can appoint one or more, so many, right? Because I don't have any thick line or anything, so that simply means many. Now, if I want to store some specific information, like simply for project and department. So here we have a ternary relation. So ternary relationship means that using this relationship table, we have a relation between these two. We have a relation between these two as well, right? We have a relation among all of these three using this sponsor table. Okay. So in that case, if I simply want to put some special attribute only for project and department. Only for this relation, I want to add an attribute. Okay, attribute is in Eclipse, not for employee and project. So if I put it in here in a sponsored table, then since we have other connections, that might mean that that attribute is for department and employee table as well. Okay, let me show you an example. Hopefully then thing will make more sense. So let's say between project and department, I want to know from when this project was sponsored by this department. I want to store this attribute. Okay, and only for this employee and project, not for employee and department, I want to know how long the employee can monitor this project, this until attribute we have. So if we put until and since into this sponsored table, that will be for every relation, right? Hopefully that thing is making sense. If I put until in here, I'm drawing a lot of things, sorry about that. If I put an attribute, let's say until in here, okay. So then what does it represent? So it might represent the relationship between employee and department, that this employee is in this department until this period, right? But that is not what our intention was. We simply wanted to write this attribute for this relation employee and project. Okay, that this employee can sponsor this project until this time. So only between employee and project, not between employee and department. So now we have some problem. You can see that in a ternary relationship, if I want to simply express one condition between two tables, that's what we cannot do. Okay, so what do we have to do in that case? We might need to have another relationship table. Okay, but since we cannot connect two relationship tables at the same time, what we will do, you can see that this is a rectangle box. What does rectangle box represent? This is a rectangle box, right? Rectangle box represent an entity, a table, right? So we'll think this whole thing as a table, and then we are simply connecting one entity with another entity using a relationship table. Hopefully that thing is making sense. This thing will especially come into effect when you are trying to connect one ERD with another ERD model. Okay, let's say you have an ERD model for some module, you have another ERD model for another module of the software, and you are trying to integrate everything into one. At that time, you are trying to connect one ERD with another. So we'll think the whole ERD as a table. We'll think the second one as a table, and then simply we'll put a relationship between those to create this application. Okay. Someone is saying, what is the code? We'll talk about that later. Like I said, software, is it easy to do in SQL? But this chart is quite confusing. Don't worry, next week I'll show you how you will simply convert this one into SQL table. Okay, exactly this figure I'll show how you can convert this one into a table. Okay. We don't have to worry, next week that is what we are going to learn. So that is what all I had to talk about today. So we learned about entity, how to represent entity, attribute, single, composite, multi-value, derived. We learned about relationship and cardinality constraint. Later we learned some advanced things like weak entity, inheritance, that simply means that specialization or generalization, and then final aggregation. Okay. Same question, someone was asking, which notation should I use for labs, assessment, or my final exam? Okay, so use the notation just outlines in this slide, which is chance model. Okay. Now, how to draw? This is draw.io. I will write that one in chat box so that anyone is not familiar with that can have a look. You can use anything. Okay, any software. If you can't do any use any software, you can draw this one in Microsoft Word or PowerPoint. That's also allowed. Okay, so it doesn't matter which software do you use, as long as you follow the notation that we have shown you, then that's fine. Okay, In draw.io, we have all of these things already created there. You can simply drag and drop. So you can see attribute with underline. So that simply means that is the primary key. Normal attribute we have weak entity, we have entity there. So let's say this one entity, this is another one, and I need to put a relationship between these two. Right? So think about, let's say, this student table. This is course table, and this is enroll table. If you want to create attributes, so this one is underlined. Let's say this is SID. Underlined simply means this will be the primary key. If I want to take another attributes, let's say the name of the student, that's what I'll do. So for the course table, same thing. Let's say we'll have course code and course title. Okay. Then we connect. Right. So you simply connect these three. And then connect all the attributes that you have in here. Okay. This is how you will connect all the attributes, and then you can use. So again, like I said, you can use any software. In your tutorial session today, your tutor will show you the software that they prefer, probably. Okay. Like I said, you can use anyone, anything, any software, as long as you follow the notations that we have shown. Okay. Everything's fine. That's it for today. Today we talked about chapter 2. Next week we will talk about chapter 3, where we will learn about relational model. Okay, drawing the relational model. See you next week. Don't forget to form groups. I have already seen that most of you, like 50% of you, have created groups. 50% you have not created groups. So create the groups, find other students.